In this video, I would like to show you a series of demonstrations of using variables, memory addresses, pointers, CRAs, and other features using an approach that I call paper pointer or paper computer, using this simple template. I already downloaded this file, which is just a text file that you can also download, and I'll use it to demonstrate a chunk of memory with memory addresses A0, A1, A2, and so forth, AF, B0, B1, and so forth. And we will try to use different C++ code fragments and see what impact they make on the usage of this memory and their addresses and everything else. So we will designate what are numeric values we're dealing with, what are the data types, what C++ language constructs we're using in this exercise. These double subdivisions indicate that the size of an integer here is 4 bytes. So one character can be stored in a single cell over here, which is 1 byte of information, and an integer will assume that an integer data type will occupy 4 consecutive bytes in computer memory. And for our reference, I just use these subdivisions where the integers will be stored. To use this more effectively, I will try to create the split screen right here, so we can use the lower part to run our examples. And I'm using a sequence number just to use it as a reference as we move along through our example. So example number 1, integer x equals 0. So let's assume that the value of x, this integer, is stored somewhere. We can choose perhaps this location, and we can say that this is our variable x, and it's occupying this space. Perhaps we could use this type of notation right here. And the value that we store in these 4 bytes in this integer cell will be 0. The data type, of course, is an integer because we're creating an integer, and the language construct is a declaration. Our next example would be creating a pointer. And at the beginning, I would like to initialize this pointer by using C++ keyword null ptr, which indicates null pointer, simply fills the pointer variable with all bits set to 0. A null pointer is indicating intentionally that this pointer is not yet pointing to any object, because I will assume that my pointer is the same size as an integer. I could potentially place it right here in this space next to variable x. So this will be variable p, which is a pointer, and will occupy the same space, 4 bytes. And of course, the value that the pointer stores is currently initialized by this keyword. Simply stores all zeros in every bit of this variable. So we can say that numeric value of this declaration of pointer could be 0, or we can say null pointer. The type of the pointer is int with an asterisk, you recall that the asterisk is a type modifier, so it basically indicates that this is an address of an integer. So pointer storing addresses of integers. And of course this is also a declaration, because pointer is just another variable in computer memory and it will store addresses of other objects. Let's try another example. Number 3. And I write $x. So let's start with the language construct of this code fragment. This is not a complete statement. Ampersand, as you know, is the address of operator applied to the name of an existing integer in computer memory. So altogether this yields a type of language construct that we can refer to as an expression. Every expression has the type. So the address of a variable, because variable is of type integer, will be an address of an integer. An address of an integer, we already know how to write. It's just like this. So the address of x, or $x, returns back a value of this type, address of an integer. Compiler has this data type which uniformly identifies data types and recognizes pure integers and addresses of them. So this is a uniformly an address of an integer. Numeric value here would be an actual physical value of this address. And since we decided to place our x in this location in memory, its address we can write it down as A0. So the numeric value here will be, let's use hexadecimal notation for addresses. We can say 0x A0. So this is an actual address of our variable x in this imaginary fragment of memory where we're trying to place our variables.